how many even 3-digit numbers with no repeating digits can be formed? This is different than 6 because I gave you only a specific amount of digits. The bottom line, I didn't give you a specified amount, so you can use 0 to 9, right? So it can be asked in different ways. This one is a 3-digit number and even, so I know it needs to end in an even number. I have the eraser. I know it needs to end in an even number. It needs to have 3 blanks, and I cannot repeat, so I have to box and hold. Even number, can't repeat, means I have to do cases, right? Even cases, every single time. If you're given the option of being able to have a 0, right? Before I forget. Right. So, 1, 2, 3. So we have either a 0 option or we have the option of 2 or 8. Because those are the only other evens, right? So I can keep the 0, which is one option, hold it. Then I have 1, 2, 8, and 9, which is 4 options, hold the 9, 1, 2, 8, 3 options. Then this one I have 2 or 8, which is 2 options, hold the 2. Then for the first blank, can I have 0, 1, 8, and 9? No, I can't have the what? The 0, because then it would be a what? 2-digit number. So I only have 1, 8, and 9, which is, don't know how that just changed colors. I didn't pretend. 3. And then I have 1 and 8, which is 2, right? And the 0, because it couldn't be used here, couldn't be used here, so we have to remember to bring it back. So it's going to be 12 plus 18, which is? Now the next one says how many 5-digit, can't start with a 0, even numbers, has to end in an even number, are there if I cannot repeat? So this one lets me use all the numbers from 0 to 9. So I have 5 blanks or another 5 blanks. So it can end in a 0 or 2, 4, 6, or 8. And the reason why we split them up is if it ends in a 0, my first blank has 9 options. If it ends in a 2, 4, 6, or 8, my first blank has 8 options, right? So I have to put the cases together that can end up with the same number at the front. So if I end up with a 0, then I have 1 to 9, which is 9 options, right? Box the 9. This one, if I use 2, 4, 6, or 8, I use the 2, I have 1, and then 3 to 9, which is actually 8 options. Do you see if I pick 2, 4, 6, or 8, I have 8 options at the front. I pick 0, I have 9 options at the front. That's why I have to do them as separate cases. It gives you a different amount of options at the front. Okay, I'm going to finish this one up. I just want to prove a point. So I box the 9, then I have 1 to 8, which is 8 options. Box the 8, I have 1 to 7. 7 options. Box the 7, I have 1 to 6. 6 options. Then here, I have 2, 4, 6, or 8, which is 4. Then I have 1 and 3 to 9, which is 8. Box the 1, and then I have 3 to 9, which is 7. What do I have to remember to do? Bring back the 0. I couldn't use it at the end blank because I could only use 2, 4, 6, or 8. I couldn't use it at the first blank because then it would have made it a 3-digit. I have to remember to bring it back. So it's 0, so it's 8. Box the 0, I have 3 to 9, which is 7. Box the 9, I have 3 to 8, which is 6. When you do that, what do you get? Anyone have that?
13,776.
700, sorry, what cost?
76.
What is the answer in the previous class? I would say yes. Okay. Go forward. Today we finish up combinations, and then tomorrow we do a review with all the terms and comms mixed and see if we can figure out how to do the questions, right, when they're all together. And then Thursday, Friday, we do binomial theorem, and then we're done a unit. So on Monday, your hand-in is due. And you don't get class time to work on it, right? It's a hand-in practice questions for you to practice at home. Can you ask me any questions about it, though? Yep, you could sit here and literally at lunch and be like, hey, help with 1. Hey, help with 2. Can you help me with 3? Help me with 4. Help me with 5. I won't even judge you. I will help you. I will judge you if you haven't even read them. And you come to me like, can you help me? Remember, you have to try them first yourself. Okay? All right. So here we have the value of n when we have this. So first thing I do is I rewrite the question. What I do not want to see is you tell me I ran out of room, Mrs. Lepp, or you're working in like a C order because you start under where it's written. So I'll have people write a question, the question will be written in this far right, and you guys work down, and then you're like, well, I ran out of room. I'm like, no, you weren't supposed to work from the question I wrote. You rewrite the question in the far left and then sequentially do math, right? So the first step is to rewrite it, not to try and work it from the top. If you worked it right from the top in its spot, you're one of those people who's going to do that. Stop. Go to the far left and rewrite the question, and then you have room, right? Okay. So n plus 4 is the bigger one, so that's when I expand. So I get n plus 4, 1 less is n plus 3, 1 less is n plus 2 factorial, and then it matches the denominator, so I stop. They match, so I cancel, and then it equals 42. Now I expand the left, so I have n plus 4 and n plus 3. I distribute it, I get n times n is n squared, n times 3 is 3n, n times 4 is 4n, 3n plus 4n is 7n. If you do that in 2 steps, no big deal. And then 4 times 3 is 12. Equals 42. This is grade 11 math now. This has nothing to do with grade 12, actually. What do I have to do? I have a squared. I have a quadratic. I always have to do what in order to solve a quadratic?
Make it equal to 0.
Make it equal to 0.
Subtract 42.
Yes. So I get n squared plus 7n minus 30 equals 0. Then I say what times what equals negative 30. And then I say what plus what equals 7. And I bet there's someone or 4 of you in here who cannot factor, and you're still in denial. If you're that person, you need to come ask me. There always is, every semester. And it's often because you just forget. You just need to sit down and do it. If you're like, I can do these, but I can't do decomp, that's also get past denial, come in and ask how to do it, okay? And I will go through decomp with you. The worst thing you can do is sit here silently, knowing you don't know how to do it, because I can't read mine. Kind of grateful for that. All right. So, what multiplies to give me negative 30 and adds to give me 7?
10 and negative 3.
10 and negative 3. So I can go straight to brackets because it has a plus 1 in front of it. If it doesn't have a plus 1, I have to do decomp. If you're like, what the heck is decomp? Come in and ask questions, because that means you don't even know what decomp is. I will never judge you. I don't care what you do know from before or what you don't know from before. I just care that you come in and ask how to do it, okay? I will not be like, you don't know how to do that? Not in a million years will that come out of my mouth. You might have done grade 11 math in first semester, and it's been a whole year and you forget, right? No judgment, I promise. So you'll have n plus 10, n minus 3. And so we get n equals negative 10 and n equals 3. Greatest thing about solving, you should cry or you should be happy. There should be no in between. You should cry because you know you're wrong, or you should be happy because you know you're right. Solving is the best thing ever because you check it. You plug it back into the original, and if it works, you're happy. If it doesn't work, you know you screwed up. That's it. You should never walk away from a solving question where you're finding out what the variable equals number. That's called solving. So when you get a variable equals number, you should know if you're right or wrong. There should be no in between. I love solving because there's no guess. Like, did I get this right? You should never be asking yourself, I either got it right or I didn't. Okay? Because the original looks like this. I just plug it into that and see if it works. That's it. You should always check them. People I remember in grade 10 when I used to teach, they'd be like, do I have to check? Yeah, you should, because you want to know if you're right or not. Every single time they're solving. It's the greatest thing ever. I love solving because it's not like a, did I get it right? You know you did. So I go negative 10, and I don't remember, is it 4 and 2? Yeah. Plus 4 factorial over negative 10 plus 2 factorial equals 42. And then I get negative 6 factorial over negative 8 factorial equals 42. Is that possible? No. So you go like this. So if left side doesn't equal right side, so my left side does not equal my right side, if that happens, then I can go like this even too. Left side, right side. That means this is a solution, correct? That is an answer. When you get n equals negative 10, that is a solution you got. You solved, you got that solution. It just does not work. So I circle it or box it. I put a line through it and I say extraneous. Then I check the other solution. Both of these are solutions. Both are solutions, totally solutions. Now I'm going to check the n equals 3 one. I'm going to put it over here. N equals 3. I'm going to check this one. So I plug it into my original. I can go LS, I can go RS for left side, right side. And I can go 3 plus 4 factorial over 3 plus 2 factorial equals 42. So I'm going to get 7 factorial over 5 factorial equals 42. I don't even need to type it in because I can do the math I did before. 7 factorial is 7 times 6 times 5 factorial over 5 factorial. You could type it in, but I don't need to. Now, when you say left side equals right side, at this point you're like, left side equals right side. Unless my child, who's now in grade 4, I keep using her, she was in grade 3 last year, I have one in grade 4, I have one in grade 7. Unless both of my children could look at this and say, yeah, that left side actually looks exactly the same as the right side, you can't go LS equals RS. My kid can know absolutely nothing about the math you say, and she would look and say, yeah, it's an image. This image, 7 times 6, 5 thingies crossed off with some exclamation marks, Mom, does not look like 42. And I'd be like, you're right, child. Those do not match. That means left side does not equal right side at this moment, right? So you have to go one more step. And then you would go 7 times 6, 42 equals 42. Now would my child say, those images match, 42, 42. That's right. Now I can say left side equals right side. So unless a young toddler could look at it and say, those images are the same, you are not done. Left side does not equal right side. Does that make sense to you? So some people will say, well, but left, those are the same. No, they are not. That is not the same as that. If I showed that to you before the factorial symbol and didn't explain it to you, you would tell me those are not the same. You have to go that one more step. Use a little more pencil. All right, 42 equals 42. Okay? Now, I know this is my solution. I walk away from this question feeling 100% confident in myself because it worked, right? I at least know I got one question right on my test. I love solving. Solving is the best thing ever. You can check it. Okay? It's also the worst. If you check it and it doesn't match, you're like, oh, this is so wrong. You know it's wrong, but at least you know it's wrong and you can go back and try again, right? Okay. We're going to flip back to our notes. Whatever they are in here. And we are here. Example 1. It says page 9 on the bottom. So, 3 students from a class of 10 are chosen to go on a school trip. 3 students from a class of 10. So I look at those 3 students and I say, does it make a difference if you pick first, second, or third? It's the ones you choose that it matters. So picking 3 students to go on a school trip. If you're picked first, second, or third, does it change the outcome? Nope, it doesn't. So if you pick first, second, or third, it doesn't change the outcome. So it is a permutation where order matters or a combination where order doesn't matter? Combination. So these ones are easy. I would just go 10, C3. And I won't make you do the formula, but just type it in. So we're practicing 10C3. What do we get? 120? Perfect.
Yes, 1, 2.
And then we're going to flip over. Okay. Here we have the Lotto 649. It's called the Lotto 649 because you choose 6 numbers out of 49. The order in which the 6 numbers are chosen doesn't matter. It's on like a little sheet. You like box 6 numbers out of the 49 numbers. And if those 6 numbers come up, you win. Not if those 6 numbers come up in the order that you picked them, right? It's just you have a sheet with the 6 numbers, you box them, poof, it comes up, and on your little ticket, it'll give you the numbers in order from lowest to highest. Literally all I know. I think I've bought 2 lotto tickets in my entire life, but that's all I know. So there's 6. I'm still waiting to win, but I don't buy any, so I don't know how this is going to work, but I'm going to try it out anyway. So there's 6 numbers on there, and they're listed from low to high, right? So the order doesn't matter. So it says here, to win the Lotto 649, a person must correctly select 6 numbers between 1 and 49, inclusive of 1 and 49. Jasper selected the 6 numbers from the birth dates of his family, 3, 7, 9, 11, 20, 29, which is irrelevant to this question. How many different selections of numbers could he have made? He made those, but how many could he have made? How many different tickets can be made out of these 6 numbers from 49, right? So How many numbers do we have to choose from? 49. They appear on the ticket in order, so does the order matter? No. So we do C, and how many are being picked at a time? 6. So it's 49C6. Which is 13,983,816 different tickets that could be made. So you'd have a 1 in a 13,983,816 chance. However, you actually have less than that or more than that, depending on if people are picking the same ticket as you, right? Because just because you chose those 6 numbers doesn't mean it kiboshes someone else from being able to pick those 6 numbers, right? So some people will say, well, if 13,983,816 people bought tickets, then someone would for sure win. Nope. Someone doesn't have to win because you can have double or triple tickets. So if you have the same number as someone, you split it. Or sometimes no one has it, even if that many people bought it, because no one has those numbers, because of the 13,983,816 people, 100 people have the same ticket, right? Okay. Here we have the athletic council decides to form a subcommittee of 7 council members. So they're forming a subcommittee of 7 council members. I have to have 7 people to look at how funds are raised, and they should be spent on sports activities in the school. There are 15 athletic council members, 9 males, 6 females, so 15 total. 9 males, 6 females. The subcommittee has to have exactly 3 females. Are there any jobs on this subcommittee? Is there anything special if you're picked different on this subcommittee? Nope. There needs to be 7 people. If I'm picked first, second, third, fourth, fifth, sixth, or seventh, does it change my outcome? Or am I just on the committee or not on the committee? I'm just on the committee or not, correct? There's no special jobs. So it is a combination, because if I'm picked first or seventh, I'm just on the committee or I'm not. The way to turn that to a permutation is give those 7 people jobs, different jobs. President, vice president, secretary, treasurer, blah, 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 blah. 7 jobs. It would be a P then, because the order in which you were picked first or seventh would give you a totally different outcome. Therefore, order would matter and would be a permutation. This is 7 council members. It doesn't matter how you're picked, you're just a council member. Okay, if you're picked first or seventh, you're still a council member. You're no more special if you're picked 7th or 2nd. Okay? Now here it says I need exactly 3 females. So what I get people doing is to guarantee getting a female, you choose from a female. So they'll go 6, C, 3, and tell me that's the answer. Problem is, this is a how many person subcommittee? I might have to close that one down. How many person subcommittee? 7. And I just picked how many? 3. I only picked 3, right? I need 7. So I need to supplement. They told me I needed exactly 3 females, and by saying I need exactly 3 females, they indirectly told me I need what? Exactly what? Males. 4. I need 7 people, right? So they don't have to say I need exactly 3 females and 4 males. They just need to say I need exactly 3 females, and then you go, okay, I need 7 total. So indirectly, they're telling me 4 males. So I need 3 females and 4 males. Why is it and not or? Because I need to combine them to get 7. If it's 3 or 4, I would have a 3-person subcommittee or a 4-person subcommittee. I still wouldn't have 7. Right? So that's why we have to and these. So 6C3 gets me the 3 females and multiply, because and add do not go together. And I need 4 males. How many am I choosing from? 9. And it's a C again because they don't have what? Jobs. So type that in. You can type it in just like that. It'll connect the 6 and 3 with the C. You don't have to put it in brackets, no matter what calculator you have. So it's 2520. If this was a written response, you'd have to say there are 2,520 different subcommittees that consist of exactly 3 females, right? You have to have a sentence. Next one we're going to talk about is cards. Now, if you don't know the order, how many cards are in a deck, you're not going to get in trouble because they have to specify how many different cards because it can't be a deficit because one of you played cards a lot as a child and the next one never ever opened a deck of cards, right? So they'd have to lay it out like this, or they make a completely different set. They'll say, this deck has 20 cards. They're purple, green, orange, and blue, and they're the numbers 1 to 5. Right? So they make it like a totally different deck that no one's ever seen before. Or they have to lay out the deck for you if it's cards. So, if ever you're like, I don't remember how many spades there are, and it's a test, you can put your hand up and say, Mrs. Lepp, how many spades are there? And I would say 15. Okay? Like I can help you out with that. I can't help you out how to do the question though. But I can tell you how many jacks there are in a deck. There's 4. Right? I can give you that. Okay? So here it says a standard deck of 52 cards. So normal decks have 52 cards in them. They have 4 suits, so spades, clubs, diamonds, and hearts, and each suit then would have 13 cards because you do 52 divided by 4, which is 13. 2 suits are black, which are the spades and the clubs, so that's 26, because it's half the deck. And then 2 suits are red, diamonds, and hearts, which is also 26. Face cards are considered jacks, queens, and kings. So you have a jack, a queen, and a king of all of the suits. If there's 4 suits and you have a jack, queen, and king of each, that means you have 12 face cards, right? 4 times 3. So there are a total of 12 face cards as well, if they talk about face cards. Now, are cards a permutation or a combination? Well, I have to decide. This one here, we're playing poker, and we have a 5-card hand. So if I deal you 5 cards, you pick them up. If it's a permutation, you have to play them in that order that I dealt them to you. Is that how cards usually works? No, what's the first thing you do when you get the cards in your hand?
Look at them and
You look at them and move them for depending on what card game you're playing. If you're playing Uno, you usually put them in the colors, right? You put blue together, green together, red, and I don't remember what the colors are in Uno, but because they are all different now. We have Harry Potter Uno, so they're the color of Harry Potter. But that's fine. So it's just whatever color it is, okay? If it's hearts, you put the spades and the clubs and the diamonds and the hearts together. Just depends on what club what you're playing. But cards are combinations because you get them in your hand and you move them around. If it was a permutation, you get them in your hand, you would literally have to play them in the order. The only one I could think of was war. You know, war, you have it down and you have to literally play just what's next. That's how it works. That would be a permutation. But when you put them in your hand and move them around, it's a combination. So card games are combination. So here it says, how many different 5-card poker hands are possible? 5-card poker hands. So I have how many total? I'm choosing 5 from 52, because there's nothing specific. It doesn't say hearts, clubs, diamonds, spades, queens, clubs, 4s, nothing like that. So it's 52. So if I'm playing any type of cards with a 52-card deck, and I'm choosing 5 at a time, I actually have 2,598,960 different card hands that can come from the 52 cards that look different, right? That's how many I have, which is quite a few. If you had to figure that out, I think you'd miss a couple thousand, right? So now we're being more specific. Of that maximum, that's the maximum number. I can't get one more extra 5-card hand that would look different. That is the maximum number of 5 cards that I could get different. But of those 5 cards, they're saying how many would be all diamonds? How can you guarantee getting diamonds? Choose them from spades?
No.
Choose them from what? Diamonds. If you want diamonds, you have to choose them from diamonds. Clubs, clubs. Jacks, jacks. 4s, you can choose from 4s. That's the only way you guarantee it. So I'm choosing how many diamonds? From 13, I'm choosing how many? 5. Why did you choose 5? Just willy-nilly?
Yep.
Nope. Why did you choose 5?
A says 5, yeah.
Because A says 5, 5-card poker hands. You didn't willy-nilly it. You knew why you did it. So we go 13, C5, and different 5-card hands that have different diamonds in them. There's 1,287. So if I just knock it down to diamonds, I go from over 2 million to 1,287 different hands that I could get. The next one says 4 black cards and 1 red card. How can I guarantee getting black cards? From black cards. Half of the deck is black. Half of the deck is red. The deck is 52. So how many am I choosing?
26.
26. 26 choose 4, so I'm taking the 26 black cards and choosing 4. And then I need 1 red. How many are we choosing from again? And then I double check. Did I choose 5 cards? I chose 4 black and 1 red. Did I choose 5 cards? I'm good. So I can just type it in. So now I moved up again to 388,700 because I opened it up more to black and red cards, which gives me more options. The next one says 3 kings and 2 queens. How many kings are there?
4.
How many queens are there?
4.
Did I choose 5 cards? Yeah, 3 kings, 2 queens. So I'm good. So I do 4 kings, choose 3, and 4 queens, choose 2. Only 24. What is the problem? What is for? Un problem. For
You only choose 3
the
cards.
question.
You only choose 3 cards.
Yeah, I'm only choosing 3. How many do I need?
5.
Remember how I did that 7-person subcommittee, but I only chose 3? I have to supplement with 4 in the previous question, right? Same thing here. I have 3 kings. I still need how many more cards? 2. What can they not be? Kings. Because if I chose a king, then I would have 4, and I'm only allowed 3, right? So it's 3 kings and 2, technically, not kings. Anything else but kings, right? Try that one out. So how many kings are there? 4. You're right. 4. C, 3. And means I? Yes. How many not kings?
40.
How did you figure that out?
Match.
Math and subtract 4. Yes. From 52. All of that combined. So you take the total number of cards and you take all the kings off. So 52 minus 4, you get 48, right? That's it. So 48C2, and what do we get? For our answer? Okay. Next one, try it out. 4 aces. Go. So this one, we need 4 aces. Is that 5 cards? No. We need 4 aces and 1 what?
Any other card?
Yeah, not ace. So we would do 4C4 and 48C1. I don't need to type this into my calculator. You want to know why? Let's look at C's are easier to figure out. P's are easier to figure out because you can put it in lines and you can actually literally see what the permutation is doing, right? C's you can't, but you can think about it as toys like we did yesterday. So if I have 4 toys and I choose 4 and I throw them in a bag. I take the 4 toys up, I toss them in a bag. How many ways is that? 1. So when these two numbers are the same, 4C4, 10C10, 20C20, you get 1 because you take them, you toss them in, right? If it's 48, choose 1 at a time and throw them in a bag. I take 1 and throw it in a bag, take the second one, throw it in the bag, third one, throw it in the bag, fourth one, throw it in the bag, 48th one, throw it in the bag. How many ways can that happen? 48, because it's 48, choose 1 at a time, right? So when you're choosing 1, this results in whatever the number is here. 4 choose 4 is 1 way. 48 choose 1 at a time. I'm literally doing 48 toys, throwing it into a bag. So it's times 48. So the answer is 48. When they're in between, like 48 choose 7, I don't know what that is. You literally got to type that in. And what is your calculator doing? Your calculator is using that formula, remember? So you can say, thank you, calculator. Because your calculator, instead of you doing this, 48 choose 1, what your calculator is doing is it's filling it into the formula. So it's n factorial, 48 factorial, over 48 minus n minus r factorial, r factorial. So this is what your calculator is doing every single time. When it's doing the math, it's literally doing that formula. It's programmed to put it into the input n and r's into that formula. So that is what it's doing. So if you didn't have a C button, you'd have to use the formula. Wouldn't be crazy by any means. Okay, we're going to do this one down here. NC2 equals 10 algebraically. If it says algebraically, what should that scream to your head in this unit? Show your work and use the formula, right? Show your work, use the formula. if you go, now think about this. If it's NC2, I'm choosing 2 objects, my N has to be at least what? 2. If I'm choosing 2 objects, it has to be at least 2, right? 2 choose 2, 3 choose 2, 4 choose 2. Your N can't be smaller than this. I can't have 1 object choose 2. That makes no sense, right? However, you can't go 2C2, 3C2, 4C2, 5C2, 6C2 till you get 10 and say there, that's the answer. If I ask algebraically, you cannot, that is guess and check, you will get 0 because you didn't do anything algebraically. They're like, but I did. I went 2C2, 3C2. That's not algebraically. You did nothing algebraically. You used your calculator and they got an answer. So you won't get any marks. Algebraically screams use a formula. So the formula we have is NCR equals n factorial over n minus r factorial. R factorial. It's on your formula sheet, which I still have to get little plastic sleeves with me. I need to move the chair. So I have NC2 instead. So NC2 equals, this is my n, this is my r. So I get n factorial over n minus 2 factorial, 2 factorial. Then people get stuck here. However, it tells you what NC2 equals, doesn't it? What does it say? NC2 equals what? So can I take the NC2 off my board, rip it off, throw it away, take the 10, put it in its place? Can I not? NC2 equals 10. So I take this NC2, take it, toss it across with a football throw in the 10. What is 2 factorial just the same as? 2. So I just have a 2 here. I want to get rid of that 2 because the 2 is just sitting there and it's causing me problems. If you want, you can put it in a bracket. How can I get rid of the 2 down there? Multiply it. Yes. Because it's a division. It's on the bottom, right? When it's in the denominator, it's a division. So how I can get rid of that is I can multiply by 2. Cancels it here. But I do the one side, I have to do the other. So that's what you do with equal signs. So I get 20 equals n factorial over n minus 2. And now we're back to the exact same steps we did when we had that p, right? When we had the p, we just didn't have the extra r factorial. So you just get rid of it by multiplying it up. Now we have to expand. Which one's bigger, n or n minus 2? N. So I get n minus 1, 1 less than that, n minus 2 factorial matches the denominator equals 20. And then I get n squared minus n equals 20. What did I have to do in grade 11? What did your teacher teach you? Yeah, when you have a quadratic, you always have to do what before you can solve it? Set it equal to 0. I know they like embedded that in your soul. It's in there. Just dig deep. So we subtract the 20 over. So we get n squared minus n minus 20 equals 0. And I say to myself, what times what equals the outside numbers? Negative 20.
Negative 5 and 4.
What plus what equals negative 1? And the answer is negative 5. Yeah. Can I go straight to brackets or do I have to do decomp? Straight to brackets because there is a leading coefficient of 1. If it's a negative 1, can I do that? Nope. I would have to move everything to the other side and make it a positive 1 or do decomp. So here I have n minus 5, n plus 4, and I get n equals 5, n equals 4, negative 4, and then people will extraneous root it right away. Remember, we have a question. This is our question. Let's see if we get our answer matches, right? We solved. When we get variable equals number, we should always be able to put it into something and see if it matches, right? Left side equals right side. So, LS, RS. My left side is NC2, so I go 5C2, and my right side is 10. I type 5C2 into my calculator, and I say left side equals right side right now, because my child could tell me that those match. No. Yeah.
Is it possible to have a negative 4 or negative number for a 10? Just how do you grab something?
Yeah. There goes to just take negatives and just.
Well, you could if it wasn't NC2, if it was like C2, or 6 minus n, or 6 minus n factorial, let's say. Or 6 plus n factorial, let's say. If n was -4, 6 plus -4 is still 2. And 2 factorial is fine. That's why you always have to check it. Okay.
We have to show our check, or we just check it out.
I always show my checks because I don't want to lose any marks. But you could check it in your calculator technically. Unless it says, if it's a written response, always show your check. Always, always. If it's a multiple choice, I don't, whatever. Direct response, whatever. And this is practicing for proofs later in the formatting. Left side equals right side. I'm literally doing this because that is what your formatting is going to look like for proofs, trig proofs. You have to do it exactly like that. And this one is good. Always box your answers. Left side, right side. -4, C2 cannot equal 10. So left side is not equal. And we're flipping over. Okay, the next one says, these ones I would star because they're forgotten about and they're harder and you'll get something like this on a test. In a meeting, everyone shakes hands with everybody else. Okay? What we need to decide is, when we shake hands, how many people do we choose at a time? Shake hands? Okay, here's one person shaking hands. Hi, no one. I'm shaking your hand. That is weird. Like, I've never had someone actually answer one. That's impressive. Like, just walking around shaking hands with no one. Hi, pleased to meet no one. Yeah, I'm pleased to meet you, no one. I'm pleased to meet you, no one. And then you, no one. How many people come together to shake hands? Two. Some people have answered 3 to me in the past. That is weird. Like, do you like form a triquetra and then break? Or like what? So, 2. We need 2 people to shake hands. We need 2 teams to play baseball. We need 2 teams to play hockey. We need 2 teams to play soccer. They have made a match where it's 3. There are soccer games where you can put 3 teams. That would be super. I don't know how it actually works. Put 3 teams play each other. It's like, what do you do? Like, do the defense with it. Nah, defense with it. I think I would just do defense. I don't think I'd ever try and score. I would just be on solid defense. Okay, maybe not solid. I would be on defense. That's not solid. Probably is what's happening. So, in a meeting, everyone shakes hands. When you shake hands, that is 2 people shaking hands at a time. It's really awkward if it's less, because there's no one there. People will question you. It's also really awkward if it's more, because 3 or 4, I don't. What are you doing? Just fists and shaking? I don't know. Now here it says there are 66 handshakes total, and I know in elementary school they talk about total and they try and tell you how to set up word problems. When it says the word total, what are they giving you? The answer. They gave us the answer. Have we ever been given the answer yet? We always just found the answer. We've always just found the answer. So currently they gave us how many we're choosing at a time, which is 2. Handshakes, does order matter how those 2 meet? Like, does it change the handshake? Like, if I come up really fast, you'll obviously when I shake your hand. Or I like. Did it change the handshake? It's a little weirder, but it's still one handshake, right? So, I shook his hand because he was getting a little tired. A little break ski before lunch. Woke you right up. All right. So, 6 is the answer. 6 is not the answer. 66 is the answer. It is a perm or a calm. It's a calm because it didn't matter how aggressively I walked up to him. It was still a C. It was creepy, but it was still a C. And we're choosing how many at a time? 2. The question says, how many people were in the meeting? What don't we know? N. Now, guys, this is a 3-question, nope, this is a 1-question part on your diploma. It's worth 3 marks. And you go 2C2, 3C2, 4C2, 5C2, 6C2 till you get 66. How many marks are you getting out of 3?
1.
You're probably getting a 1. Not because of the answer, but because you set something up here, right? You're probably getting a 1 out of 3 due to this. Nothing to do, the answer's giving you nothing. The answer, we don't care. That is not showing work. Going to like, unless you're taking pictures of yourself, which you can't do because you don't have a phone, and then inserting them into your diploma and then sending it on the way. Like, they don't see work. There's no work, right? We need to do it algebraically. Algebraically in this unit screams go to the rhymes with formula sheet. The formula sheet. Yes, that's where we go. So our formula sheet would say NC2 equals n factorial over n minus, sorry, NCR. I didn't need to put a 2 in there. N minus r factorial. I'm giving you a formula sheet. I just need to get class sleep smart. So I'm going to fill this in, and I'm going to get n factorial over n minus 2 factorial equals 66. I'm going to get rid of that 2 factorial first. What am I going to do with it? How do I get rid of the 2 factorial on the bottom? See, can you answer this last time? Multiply. Yeah. So 2 factorial is just 2, right? So I'm going to multiply by 2, and I get n factorial over n minus 2 factorial equals 132. Then I just math like before, right? The hardest part of this should be setting up the equation at the very top. Then you're just doing the same thing over and over that we practice. This is why we practice. Remember we practiced when we're equal to 42, and I told you we're practicing this because we're going to get to a point where we have to set it up, and then we can do this part because we practiced this part. This should not be the hard part. That should be. This isn't new. So we get n factorial, which is n minus 1, n minus 2 factorial. If you've not done an ounce of homework yet, you should be very afraid. That's all I'm going to say. If you have not touched an ounce of your homework, you should be very concerned in yourself. And you should start doing it. I might do like a halfway point check to see if you've done any because I'm afraid. Okay, so n squared minus n, and then I subtract the 132 over, equals 0. And I say what times what equals negative 132, what plus what equals negative 1. Why am I concerned that people are not doing their homework? Because I have not had a lot of questions, and I know there's a few in there that you probably don't know how to do. So I only had like 3 people from this class ask questions, and I'm assuming there's a few others who can ask them, but then I'm still assuming that there's probably a quarter who are not done their homework. So what is this?
Negative 1211.
Yeah. And I can check it by going 12C2. Like I said, I do this for my own benefit. And then I say 66 equals 66, so that one makes me happy. So if I do a negative 11C2 cannot equal 66, because I have to type it in, it's not happy with me. That's extraneous. And because it's a word problem, I say, how many people were in the meeting? There were 12 people in the meeting. Then we're going to skip to extension 3 and then come back to extension 2. Extension 3 says every. Now I'm going to say every team in a baseball league, because they're playing 198 games, and football for sure don't play that. And basketball usually doesn't play that. Baseball plays a lot of games. So I'm going to say baseball. So every team in a baseball league plays every other team 3 times. That means every other team, not this team. Not like this team, but not this one. This one, but not this one. Not that. Every other team in the league. So if there's 6 teams in the league, this team plays the 5 other teams. Okay, that's what that means. In baseball, just like, okay, handshakes. 2 people come together. Shake. Awesome. Cool. In baseball, how many teams come together and play? Dose. 2 play at a time, right? I don't know where the third person team would go if you were playing 3. I'm not sure how it would work. 3 would actually be not so hard with baseball. You could like do like a rotation of playing. Like soccer would be like immensely confusing. Okay. Every team in a baseball league plays every other team 3 times. So when we see this, people will go NC3. If you put NC3, you are saying 3 baseball teams play at a time. I've never seen that. There's only 2 dugouts. I don't even know where the 3rd one would sit. You were just in the sun because you came late. Like, I don't know. So if it's baseball, hockey, basketball, teams that play 2 sports at a time, a giveaway should be, it should be NC2 because 2 is how many play at a time. NC2 represents everyone playing every other team once. Right? NC2 was everyone shaking hands with everyone once. Right? NC2 represents everyone playing each other once. But they're not playing each other once, they're playing each other how many times? 3. So what am I going to have to do? Take this and do what with it? I think you're saying it right, but you're whispering, so I don't know. Times it by 3. I'm going to teach how you guys answer. That's how you answer, okay? Or I could answer how sometimes you answer. NC times 3, 100 and like you guys like you bigger. 100. Like you just let the rest go. 198. Conviction, people. Conviction. You are smarter than you. And when you whisper answer, that means you do not think you're right. That scares me because I have walked around and you're all right. So conviction. Believe in yourself. I believe in you. You just need to believe in yourself. When you whisper answer, that means you're scared your answer is wrong. And trust me, if your answer is wrong, I could somehow twist it to possibly being completely correct, and then we move on and I still ask the answer. So if you're like, the answer is 4, I'm like, 4 is a really good answer. I like 4. 4 is my favorite number. 4 is continuous. 4 is awesome. What could the answer also be? And then you're like, 1,192. I'm like, that's correct. And we move on. And I can make your 4 sound like it wasn't stupid. I can play it. It can be great. Just answer an answer. I can twist it. It can be a great answer. Might not be right, but I will convince half the class it is. We will move on. We will get the right answer. We will write it down. You will not feel stupid. I promise. Okay? Good. All right. What's the first thing I could do here? Yeah. Divide by 3. Some people will keep the 3 and then it confuses them. Just get rid of it right off the bat. We divide by 3. We get NC2 equals 66. Huh. Was exactly what we had up here, wasn't it? So I'm going to save time. Do not save time on a test and be like, see, above, extension. But that's what we can do. Extension 1 does have the work, right? So when we did extension 1, I'm doing this because this is notes and time saving. We got n minus 12 and n plus 11. And we got n equals 12 and n equals negative 11. You need to show all the work from above, right? I'm just saving time. C extension 1 for algebra. Then we're going to go up to extension 2. Extension 2 talks about a circle with 6 closed dots on it. So draw yourself a circle with 6 closed dots on it. Doesn't matter where the dots are. It's extension 2. It's the one in between here. Circle with 6 closed dots. Like it doesn't matter where they are. So 6 closed dots. No, because it says they're on the circle. So it says here, there exists a circle with 6 closed dots on the circumference. So it's on the outside of the circle, right? Circumference is all the way around. Okay. Then it says, how many triangles can be formed using 6 dots? How many of those dots do I need to make a triangle? 3. So most people will get to this. And then if they're Crystal in high school, you're like, ooh, 50-50 guess, P or C. I'm just going to wing it. I'm going to put a P or I'm going to put a C. I don't know which one. That's what I'm going to do. We do not want you in that boat. We do not want you in the Crystal boat. That was the boat I was in. It is not a good boat to be in. That's still a 50-50 answer, right? So what we have to do is we have to look at this number. We always look at the one we're choosing, and we say, if I choose the dots in a different order, because this is dots this time, does it change my triangle? So if I pick the dots in a different order, does it change my triangle? Well, let's see. I'm going to pick them in this order. Then I'm going to pick them in this order. Did it change my triangle? Did the order in which I picked the dot make a different triangle? No. So does order matter in the 3 dots you picked? No. So what is it? It's a C. And this is an answer. So you can get 20 different triangles. And then the last thing we have to go over is the standard of excellence questions. They're at the bottom. It says, at least and at most cases. So these are standard of excellence, which makes them sound hard. You practice them enough, they're really, really easy. You see this on a test or on a diploma, and you're like, well, this is an easy question. They call it a standard of excellence. Standard of excellence is not equal to hard. Okay? If you were given this question and never having ever tried it before, yeah, it would equal hard. But because we're going to practice these, you're going to see them and be like, oh, at most and at least, if I see that word, it means I have cases. I have cases. So here we have 12 adults and 18 kids. Whenever I get something split up like this, I'll say, okay, well, that's 30 total. And I always give myself a total, because if they just ask me for like a 5-person subcommittee, then I would do 30C5, right? I don't care that there's adults and kids. I don't care. If they say I need 2 adults, then I have to get 2 adults and kids. Then I have to split them. All right? So we keep reading here. It says, I have 12 adults and 18 kids, and they're on a prom program planning committee. A smaller group of them, 5 people. So I know no matter what, I'm going to need 5. 5, 5, 5, 5. Every group needs 5, right? I need a smaller group of 5. And they need to decide on themes. How many different ways can a smaller group subcommittee consist of at least 4 adults? So I go to my 5 people that I'm choosing. And I say, does it make a difference if I'm picked 1st, 2nd, 3rd, 4th, or 5th? Is my life any different if I'm picked 1st, 2nd, 3rd, 4th, or 5th for that subcommittee? Nope. So what is it? A com. How could I change this question to make it be a permutation? Give them roles. Give them something different. Heck, hand one a chocolate bar, hand one a sucker, hand one a bag of chips. Like, you just make it different. If you even just hand them a sucker and a bag of chips and a chocolate bar and, I don't know, granola bar and popcorn, you've now made it a permutation because the order in which you pick those 5 changes. Okay? All right. So this one we know is a combination. It will always be a combination. It's a 5-person committee with no jobs. So it's a combination. Now here, I need at least 4 adults. Think of it as money. When it's at least or most, think of it as money. I'm going to a store and I need at least $4. What does that mean? $4 or more or $4 or less if I need at least $4 to buy anything? $4 or more. So if I need at least 4 adults, I need $4 adults or more. Okay, so let's try it out. So I need at least 4 adults. I need 4 or more. So that means I need 4 adults or what? Nope. 4 adults or how many next? 5 adults. Or could I do 6 adults? Like there's 12 adults, so I should be able to do 6 adults. Why can't I do 6?
Because there's only 5 people.
It's a 5-person subcommittee. I have to stop at 5, right? Now, every case needs to have how many people on it? 5, right? These are cases. So this is one person, this could be one subcommittee, or this is another subcommittee. That is an adult. I didn't, but yeah. So this is one subcommittee, this is another subcommittee, or another subcommittee, or another, and I keep going, right? But every single one of those subcommittees has to have how many people? 5. This one has 4. So could I go 5? Could I add another adult and make it 5? No, that would be this case. What do I have to add to this one to get 5? The kids. I have to add kids. So 4 adults and 1 kid. Do I need to add anything to this case to get 5? No, it already has 5. And then I just choose kids from kids, adults from adults. It's the only way you can guarantee getting adult, choosing it from an adult. So there are 12 adults and 18 kids. So I do 12, choose 4, and means I multiply. 1 kid, 18, choose 1. Or means I do what? Add. 5 adults, what do I do? 12C5.
Couldn't you technically do, for the 4 kids, like, could you do 12C4 times 26C1?
Nope, because then you're getting an adult.
Yeah, but could you add the adults and the rest of the adults and kids, and then just get like a regular?
No, because then you could get 5 adults, and that's this case. If you're using 26, you're chancing getting an adult here, which means that's a 5 adult one,
Yeah.
which is this case. This case can only have 4 adults. It can't have 5 adults. That's this case. You have to do them separately. So this has to be 4 adults, and then this has to be 1 kid. Then this is 5 adults. So you can't have more adults than per case than 4, or you're bleeding into the next case. Yeah. Yeah. So this you can just type in just the way it is. You don't have to put brackets or anything. It doesn't matter what calculator you're in. Because it'll do order of operations, which means it'll do the adding last. 9702. Then we're going to flip over. This one here says at least 1 adult. So if I went to the store and I needed at least $1 to buy anything, what would I need? $1 or more. $1 or more. And where am I going to stop at on this one? 5. So this one's going to be a whole bunch of cases. We're going to show method 2 in a second over here. But this is just the literal one, just like we did. So at least 1 means I could have 1 adult in this case, or the next case I could have 2 adults. Or I could have 3 adults, or I could have 4 adults, or I could have 5 adults. And why am I putting lines under it? Because those are all separate subcommittees. Like this is one subcommittee I could have, or another one, or another one, or another one, or another one, correct? And every single one of those subcommittees has to have how many people on it? 5. The first one needs how many kids to supplement it? 4. The second one needs how many? 3. The third one needs 2. The fourth one needs 1. The fifth one needs nothing. It has 5, right? Could you go 0 kids? Sure. Now, how do I guarantee getting an adult? Choosing from 30? From all 30? From the 12 adults. And the kids I have to choose from? 18. So here I go. 12 adults choose 1. And 18 kids choose 4. Plus, now I start a whole new case. So I get all the adults back and all the kids back. Because it's a whole new case. I still have my 12 adults and my 18 kids back. So now I do 12 adults choose 2 times, because and 18 choose 3. Then I get a whole new case again. I get my 12 adults back, my 18 kids back. 12 choose 3 times 18 choose 2 plus 12 choose 4 times 18 choose 1 plus 12 choose 5. Now you can type those all in and get the answer. I'm not going to type those in right now, because I'm going to show you a quicker way. Now, this is a long way. It will get you the right answer. If this may make sense and the second method doesn't make sense, you do whatever method makes sense to you. I show 2 methods, not to say you have to do method 1 or method 2. I show 2 methods because whichever one works for you, you do. Okay? So this one had a lot of cases, right? Perhaps there's a faster way. So when I told you that I wanted all the people who could not be together, remember how we did the question where it was like Anna and Cleo couldn't be together, right? So I did total number of ways I could set them, 5 factorial. I subtracted Anna and Cleo together, and then what was left over was Anna and Cleo not together, correct? Well, what I can do is I can actually do the complete opposite of at least 1 adult. I could do all the total different subcommittees I could make. The total number of different five people subcommittees. So I would do total, just like I did total ways of sitting. So I can do total. This is the other option I could do. So the total number of different five-person subcommittees. Is there anything specified here about adults or kids or anything? No, so I'd have to use how many? What's the total? 30. So I do 30C5. C5 is 142,506. That's how many totally different five-person subcommittees I could make. Not specifying if I needed X number of adults or kids, right? That's the maximum number of subcommittees I could make from 30 people. Okay? Now if I subtract off all the cases that don't fit here, I'll be left with the ones that do. So here is at least one adult. What's the only thing that doesn't fit in on at least one adult?
0 adults.
0 adults. So the complete opposite. So I have 1 adult in here, 2, 3, 4, 5. What's the only case I don't have? 0 adults. So if I take the total subcommittees and I subtract off 0 adults and 5 kids, I will get this answer. So 0 adults, do I even have to write, do I have to show it? No. Could I? Could I go 12C0 times 18C5? Sure. So I'm just doing the complete opposite. I'm taking the total minus the cases that don't fit, right? So this is 8, 5, 6, 8, and I subtract them. Now if I add up all the cases that do fit, I get exact same answer. So which one's more correct when they're the exact same answer? They're the exact same answer. Both of them is equally as correct as the other one, right? Which one should you do? The one that gives you the right answer. So if method 1, the one that's very literal, even though it takes longer, is the one that gets you the right answer, you do this one. If method 2 makes sense to you and is shorter, use that one. Sometimes method 2 isn't actually faster. So it's whatever is easier and faster for you. Okay? Some people will always stick to method 1, and from this moment on will forget that I even talked about a method 2. You're like, nah, I'll just do this because it's exactly how it sounds. Cool, do it. Don't ever pretend I didn't even speak of a method 2. If you're like, this makes no sense and now I'm overwhelmed. Okay, cool. Didn't happen. Erase it from your memory. Like Men in Black with the pen. You're probably too young to even know what Men in Black is. It's a movie. You use a pen and then everyone forgot what would happen. Okay? Blank you from that one. Don't care. Don't use it. I'm just showing it because some people like it. Okay. I want you guys, oops, that's not what I meant to do. You guys try this one. So you try this one. You can pick whichever one you want. I'm going to use method 1 on this one. So you try it out. We're going to see if we get the same. Catch with at most 2 means 2 or less, right? Which means 2 adults or 1 adult, and then the one that everyone forgets about is
0 adults.
0 adults. You have to remember that it can be none as well. If it says at most 2 adults, it means you could have none. Did you get that? I just typed it really fast. Your homework is on the next page, but I'm just going to write it down in here. It's in your textbook. So there is that online version of the textbook, which is kind of hard because you have to look at the textbook and then you have to go like search for the answer key. So what I'm going to do is I'm just going to take pictures of the 3 pages from the textbook and the answer key and post it as page 534, Tuesday's homework, okay? So that you can just open that up. The textbooks are supposed to come by Friday. There are 17 textbooks in the library currently. If you're someone who's like, I cannot function without a textbook, if you're one of the first 17 to get there and ask for it, you can have yours before Friday. But I'm going to take a picture of that, those pages, and the answer key, and post it as page 534, okay? And so you can open that up instead of the online version, so you'll have the answers right there. If you're someone who wants to take a picture and have it on your phone, you can take a picture of my textbook too. I don't care.